This video will start with question number 41 of the Unit 4-5 test review worksheet. And let's take a look at the instructions for these questions. It says, for the following questions, show all your work, round your final answers to 2 decimal places. To 2 decimal places, class. I'm going to underline that, so just see that. To 2 decimal places. And write your final answers in complete sentences in the boxes provided. So pay attention to this because a lot of these answers are going to be in decimal form and I want them accurate. So instead of going to 1 decimal place, we're going to extend our answers to 2 decimal places. Let's take a look at question number 41. The function d of t is equal to negative 16t squared plus 10t plus 9. That function models the height of a diver over time, where dt is feet above water, so basically dt is the height above water, and t is the number of seconds since the start of the dive. So we have a diver, and we have a function that predicts how high the diver is, depending on how long they have been, or they have jumped in their dive. Okay, so letter A. At what time does the diver reach maximum height? At what time does the diver reach maximum height? Now think about this, class. You have a parabola of the diver jumping, and this expresses basically height over time. And if we're looking at time, time is the x-axis. This is time. And we know that height, I'll just abbreviate that, ht is the y-axis. So when we're looking for time at maximum height, this is our maximum height. This will be our time at maximum height, and that is the x value of the vertex. Think about our coordinate grid. We move x left and right, and then vertical or horizontal, vertical is up and down. So left and right is going to be time, our x-axis, and up and down is going to be height, our y-axis. So this is asking for the x value of the vertex. Be careful when you read this. Your brain sees maximum height and you start wanting to figure out, okay, how high did the diver get? It's not maximum height, it's time that it took to reach maximum height. And this is a standard form quadratic. So we find the x value of the vertex for a standard form quadratic with the formula negative b over 2a. Let's go ahead and identify the a, b, and c value. Let's do it up here. So the a value is negative 16. The b value is 10. The c value is 9. And that means negative b over 2a. Take the b value of 10, flip the sign. We've got negative 10 over 2 times a. A in this case is negative 16. I can do some of that multiplication in my head. That's negative 10 over negative 16. And now we're going to have to put this, sorry, I did that math incorrectly. It's negative 10 over negative 32. Put that in your calculator and you will get 0.31. Let's check that real quick. I'll check and make sure my rounding is right. So I'm just going to do 10 divided by 32. Because I know a negative divided by a negative is a positive, and this is 0.3125. We're going to round this to 2 decimal places, so 0.31 is accurate. Alright, so what is our final answer? Our final answer is the maximum height is reached. And I'm not even going to write this in here, class. I want you to, well, you know what, I'll take a moment to write it. The maximum height is reached in 0.31 seconds. Alright, so there's our maximum height, the time it takes to reach maximum height. Now let's go ahead and answer the next question, which is, well, what is the maximum height reached? And look at our diagram again. Our maximum height is reached at the y value of the vertex. Maximum height is reached at the y value of the vertex. If you look at your flip book or any of the work you've done in class, you will see the maximum height can be found by plugging in the x value of the vertex and solve it to find the y value. All we got to do is write the equation. This is going to be d of 0.31, and let's plug in that value for every x value in our equation. Remember, when you plug in a variable, you do it in your calculator in parentheses plus 10 times 0.31 plus 9. Okay, put that in your calculator, check it out to make sure you are doing it correctly, and you're going to end up with, rounded to 2 decimal places, 10.56. So what is the maximum height reached? The maximum height reached is 10.56. Let's check our unit of measure. The question says we are measuring in feet. You can see feet right here in the question, so we know the unit of measure is going to be feet. Now question number 42 is answered the exact same way. So we're going to go through this process one more time to practice this. The function d of t equals negative 4.9 t squared plus 3t plus 3 models the height of the diver over time, where d of t is meters above the water. Now we got a different unit of measure, meters above the water, and t is the number of seconds since the start of the dive. So we're still doing seconds, but now we're measuring in meters. At what time does the diver reach maximum height? Again, we can verify. This is a standard form quadratic, no parentheses, so it's going to be standard form. And that means we're going to look for the time. At what time does the diver reach maximum height? Time is on the x-axis, so we're finding the x value of the vertex. And the x value of the vertex is found with negative b over 2a. Let's identify a, b, and c. A is now negative 4.9, b is 3, and c is equal to 3. So negative b over 2a, our b value is 3. We flip the sign, that turns to negative 3. And the denominator is 2 times a, which is negative 4.9. Put that in our calculator, and you will get negative 3 over negative 9.8. And when you put that in your calculator, the final answer is going to be, this is rounded, 0.31. It actually ends up the same, close to being the same as our previous question. I'm going to correct something here real quick, class. This actually should be, technically, it should be approximately. So if you correct this to show approximately 0.31. And then down here for our x value of our vertex, we also have it's approximately 3.1 or 0.31. So I'm not going to write this answer. You can write the same way. The maximum height is reached in 0.31 seconds. And then what is the maximum height reached? Again, we're looking for maximum height now, so now we can look for the y value of the vertex. Let's take our equation and plug in our time at maximum height. So d of 0.31 is equal to negative 4.9 times 0.31 squared plus 3 times 0.31 plus 3. Write it this way, class, so that you know you can put it in your calculator the exact same way, and we end up with about 3.46. And I don't remember whether it's exactly 3.46 or approximately 3.46. Let's take a look. My calculator is not as nice as yours. Let's go ahead and try this. I'll clear this. We got negative, 4.9. That's going to be negative. Yeah, my calculator is not going to let me. Here, let's clear this. I've got another calculator available, but I don't have it loaded up right now. So I'll try this just for the heck of it. 4.9 times parentheses 0.031 parentheses squared equals. So I've got that number. Let's try this. Plus, I'm not sure if it's going to work or not. 3 parentheses 0.031 parentheses plus 3 equals. Yeah, so my calculator is going to actually make mistakes on this because of the order of operations, and my parentheses don't work the same as yours, so I'm not going to worry about that. I do assume this is an approximation, so you had to round it. Remember, we're rounding to 2 decimal places, so we ended up with 3.46. And so you can write your answer here. The maximum height reached by the diver is 3.46, and don't forget our unit of measure is going to be meters instead of feet on this one. Alright, we will start up with question number 43 on the next video.